Okay. I think we're live. And the microphone might stay on. We'll see. Give everything a second to warm up. Give Twitch its time to catch up with me. Let's see where we're at. Okay, looks good. I changed the resolution a little bit, and I also made myself smaller, so hopefully I'm not in the way of the action. Alright, so let's go ahead and get started. Yesterday, we went over the command pattern kata, which, like all patterns, contains an abstraction at its core. So it's attempting to abstract away some part of your code into a, I could say reliable, but consistent and predictable format. So for the command pattern, we're looking at a way to process requests. And we don't want the abstraction to need to know anything about the request or the response, necessarily. And just like in the factory pattern from week 1, we are abstracting away the creation of an object. And then in week 2, we did the behavior of an object. Then in week 3, we did the connection of encapsulated properties in an object. We're abstracting that away. This time we're going to take a pretty high level abstraction, which is the way your application domain as a whole processes requests and returns results. So inside of our game engine folder, we followed the kata pretty much verbatim. We started off with our actions that are possible. So fight, heal, repair, negotiate. We then created our request and our response objects, which we might change on Saturday during our refactor Saturday, which we'll release to clean things up and reflect on a week's worth of work. But we said for our request, we just want to take in the game action. So as you as a player might request that you heal, the text that goes along with that, the sender being you, and the target being whatever you want to heal. And then our response, we decided to keep it really simple, and we're just going to return a message, so a string. And as our first kind of tweak, I'm going to take out the string text resource. I'm not quite sure where we get that from. I think it just adds noise for right now. Okay. So, then also following in the kata, we had to create an invoker, something that's going to take in our request and pass back a response. The thing we didn't do with the kata yesterday, which is create a game request interface or a command interface, so we can start attaching that to different things so that they can also process requests. So let's go ahead and do that. Let's call that iGame command. Make that a public interface. And all we care that it returns back is a response. And we want it to be called execute. And we want to take in a request. Okay. Yesterday we also talked about being able to add things to a list and to target them and so they'd be a reference from that point forward. So we can target them as we like, and those updates will reflect in that source list. So inside of our hive mind, we want to get a list of game objects, or just the entire world, we'll say that, which is a grid. Make a public for right now, so we're going to say a grid, which we know to represent our world as a getter and setter. Let's go ahead and give hive mind a constructor. And so when you create hive mind, as its first responsibility as our game engine, it's going to create a new world. Okay. Let's close out actions for a second. Let's go ahead and steal this bit of code. And slap that there. So now, when we create a new hive mind, we'll have a world. So we can point to hivemind.world if we want. So now everything else stays the same. We're still adding rooms and all of that. So we're also setting the stage for doing a flyweight pattern later on. So I won't go too deep into that now, but the flyweight pattern is going to be a way for us to share resources. So if you think about whenever you boot a game and it takes that initial time to load its assets, and then aspects of the game will borrow from those loaded assets. That's what we're doing. We want to be able to load all possible objects into a list, and then or dictionary, and then have other parts of the game share that same set of assets. But for right now, I think it's good enough just to know that our world is encapsulated inside of the game engine. Okay. For our game command, if we go into our iGame object, we would like this to force all game objects to be potential, I want to say recipients of commands, but we already, in a sense, we already have that. So let's not put it here. We can make all of our actors have to be implementers of the game command. So they have to have a way to execute. We could do that. Stick it on the iActor. We've got some choices. We could go all the way into the player object and throw it on top of iPlayer. That wouldn't be too terrible. We would have a bit of redundancy. Let's start with the iActor and see how far that gets us, just so we aren't staring at the screen for too long. Alright, so putting on the iActor, we're naturally going to go into the base actor, which inherits from the iActor, and it's going to say, you are missing this. So we can say for all of our actors, we want to var action type is equal to request dot game action switch on the action type, and then for the case of fight, we can say return new game response. We want to call this dot fight. Return new response. I'll just say blah. Default. Alright, so this would work. Any player or monster would be able to execute a command. Hey there, Tristan34. Glad you could make it. We're fighting with some architecture right now. We're fighting to see what we really want to do. So the problem with putting our game command on the actor is inside of our world, we're going to be building a list of iGame objects, so we wouldn't be able to call execute on the one we find. So I think the smart thing here is going to be to put it onto our iGame object so that anything in the world can respond to a command. So Tristan says I pronounced their name correctly, or his, or their. And my full name is Arinze Chuku, so I am very sympathetic to name pronunciation. I don't get it right 3/4 of the time. It just means that when people mispronounce my name, I am never offended because I know how hard it is. Alright, so our iGame object, every game object is going to be able to process a command, which I think is good. So even if that command was you trying to repair a player, and the response being, why would you want to do that? Or you can't repair a player. Try something less animate. So whatever that is, we definitely want that kind of good coverage, so you can target anything and get a response back. Okay, so because we had an interface to our game object, we're going to build just so we can see the places where it broke. Thankfully, we don't have a super complicated game yet, or even application, so it's not breaking out of places, but this is definitely one of those refactor points where you can get a lot of errors. I was at work today, and I put in I pointed